Hi guys, Chapter 0 is about preparing for algebra and Section 2 is introducing us to the real number system. So by the end of this lesson you should be able to classify real numbers and then use those real numbers. So let's talk about the number system that we deal with. So any of the numbers that we're going to talk about in this class can be plotted on a number line. When you get to Algebra 2, some of the numbers you talk about won't be able to be plotted on this, but we'll save that for a later date. So there's really two sections of numbers on a number line. You have the origin, which is 0, and anything at 0 is not really positive or negative. This is just nothing. 0 represents nothing. And everything on the right side over here is all positive numbers. And as this keeps going forever and ever and ever, it gets more and more positive. Where on the left side, as we go down this way, our numbers get more and more negative. So think of like a bank balance. If you keep withdrawing stuff out here, you're going to owe more and more money. And then we break down these real numbers into several subgroups. And the first group that we're going to talk about is natural numbers. And natural numbers are also called counting numbers. So stop and think, if you were going to count something, what number would you start with? Hopefully you said 1. So 1 is our first counting number. And then you would go 2, 3, 4, 5, 6, 7, 8, and you would keep on going forever and ever until you counted however many things you wanted. Counting numbers do not include 0 because you wouldn't count 0 of something. You wouldn't have to count it if there was 0 of something. So think natural numbers are counting numbers. Where whole numbers are your counting numbers plus 0. So I always think whole has an O in it. It looks a lot like a 0, so it includes 0. And then all of our natural numbers. And it goes on forever and ever and ever. Integers are the numbers that you are probably most comfortable with. And integers are both positive and negative, nice pretty numbers. And we're going to call pretty numbers the ones that don't have decimals or fractions. So all the ones that we've mentioned, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but then also the negative version of that. So sometimes it's also called the natural numbers and their opposites, because remember opposites would be if like you had 1, opposite is -1. So we'll write that, oh no, go back. Naturals and opposites of your natural number. And it still goes on forever and ever in both directions. And then rational numbers are numbers that can be written as a ratio. And those are anything that is a fraction, anything that you can write as a fraction. So like the number 2, I can write as a fraction. I could write it as 2 over 1, or I could write it as 4 over 2, or I could write it as 8 over 4. All of those are the same number on the number line. It's 2. So to include all of our rational numbers, not only is it all of these dots that we've had for all of these other ones, but it's every single number that we have in between too that we can write as a fraction. So then we have rational numbers, which we just talked about. They can be written as a ratio, but there's also something called irrational numbers. So let's talk about the rational numbers. These are the ones we're most comfortable with. They're fractions and decimals have to either terminate or repeat. So if you can write something as a fraction like 1/3 or like 2/5, these are both rationals because they can be written as ratios. But then if you were to type 1/3 into your calculator, it gives you 1.3 repeating forever and ever and ever. This repeats, so that means it's rational. And sometimes it doesn't repeat the same thing over and over again. Like if you had 1, 2, 3, 1, 2, 3, 1, 2, 3 over and over again, that is also a rational number. Or something like 2/5 is just 0.4. If you type that in your calculator, it stops at 0.4. And it's not because your calculator didn't want to put anything else. It's because 2 divided by 5 is 0.4. And that's it. There is no more. So this one terminates. You can think of like the Terminator. It stops whatever is in its way. So this decimal terminates. These ones repeat. These are both rational numbers, where an irrational number cannot be expressed as a terminating or repeating decimal or a fraction. So one of my favorite irrational numbers is pi. If you type that into your calculator, you get 3.1415926, blah, 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 blah. At no point in time do we have that pattern anywhere again in pi. It goes on forever and ever, and the numbers always change. So because it doesn't terminate, it never ends, and it doesn't repeat anywhere, it is not a rational number. It's irrational. A couple other irrational numbers that you are probably familiar with are when we take the square root of something that's not a perfect square, like the square root of 5. If you type that into your calculator, it doesn't repeat and it doesn't end. You get 2.236067978, and then my calculator stops. But that doesn't mean that number was done. It's going to keep on going forever and ever and ever. So we can organize all of these thoughts in a nice little grid here. So like I said, all of the numbers we're dealing with in this class are real numbers, which means that we can put them on a number line. And inside of our real numbers, we have rational numbers and irrational numbers. And remember, the rational ones can be written as a fraction, so 2/3, 5/6, 7/8. We can also have a decimal like 0.25 or 0.3 repeating forever and ever. And irrational are things like square root of 5 or pi or square root of 10 or square root of 20, things like that. Irrational numbers don't have any subgroups, but the rational numbers we can get more specific with. So if you're one of these rational numbers, a rational number, remember, could be something as simple as 3, because that can also be written as a fraction. So if we go back and look here, under rational numbers are integers. It includes everything that a rational number had, without the fractions. So remember, these were positive and negative natural numbers. And then further discriminating against our numbers, integers go to whole numbers. And remember, whole numbers don't have the negatives in there. And then finally, the most discriminant is natural number. So the reason that this little chart is helpful is because if I give you a number like 5, 5 is a natural number. It's a counting number, which means that it's also a whole number, which means that it's also an integer, and it's also a rational number. And because it's a number that we're going to talk about in this class, it's also a real number. So if I ask you to describe the number system that 5 belongs to, it belongs to everything here. Now, if something was an integer, that means it would be here and at rationals and at reals, but it could not be a whole or a natural. So you'll get questions like this. Classify or name the set or sets of numbers to which each real number belongs to. So I see the first one, 5/22. It's a fraction, so automatically I'm thinking a rational number. So because it's talked about in this class, it is a real number. And you guys might see this symbol occasionally. It's an R with like 2 things on the side. That means a real number. And then we go back here, so it's real. Ask yourself, is it rational? Can it be written as a fraction or not? And it can be written as a fraction, because it is, so it has to be rational. And then we see if we can go any further. Is it an integer? And in this case, it is not an integer because it's not a natural number. It's not a counting one or a negative counting number. So this one is just a real number and a rational number. So now the next one, square root of 81. Square root of 81 can be simplified to just plain old 9. So don't think just because it's a square root that it's going to be something funky. Simplify it if you can. So this one is a real number because it's a number we're talking about in this class. It is rational because I can write it as a decimal or a fraction, so like 9 over 1. If we go back to this little chart here, it's an integer because it's a counting number that's either positive or negative. Keep on going. It's a whole number because it's a natural number or 0. And then finally we know it's a natural number because I could count out 9 things. So 9's kind of special because it fits into almost all of the categories. So last one, square root of 56. Now if you type the square root of 56 into your calculator, you end up with 7.4833144774, and then my calculator ends. Because I don't see any repeating in here over and over and over again, I'm going to assume that this goes on forever and ever, doesn't end, and my calculator just can't record it. So in this case, it's real because it's a number we're talking about in this class, but it falls in this side. It can't be written as a decimal, so that means it's irrational. And there's nowhere else to go with irrational. If something's irrational, you know that's it. You don't need to follow any more like we did for the number 9 over here. All right, the next thing we're going to do to use the number system is to graph a set of numbers on a number line and then put them in order from least to greatest. So in order to graph something, we have to plot the points named by those numbers on a number line. So if we have 5/3, -4/3, 2/3, and 1/3, and I'm looking at this blank number line here, I want to put 0 somewhere in the middle because we got both positive and negative numbers. And then I'm going to split my number line up into thirds since all of these are thirds. Like we'll make this 1/3, 2/3, 3/3, which remember is just 1, 4/3, 5/3. And then do the same thing in the other direction. You could make this whatever you want. You could have made it 1, 2, 3, and your points would have been a little closer together. That's -1. And then we just got to plot these points. So the first one is 5/3. So I'm going to come over here. 5/3 is right here. -4/3. I'm going to come over here. I got 2/3 up next. And then finally -1/3. So now if I had to order these, it's really easy to see. This is least, this is greatest. And all I have to do is write them out in the order that the dots appear. So the first one was the dark blue, so it's -4/3, this is my smallest. And then the purple, so -1/3. Then the red, which is 2/3. And the light blue, which is 5/3. Now, not all of them are going to be that easy, where everything's split up into thirds. You could get something like this. So let's look at these numbers. Before I do anything on my number line, I'm going to put all these numbers in something that makes sense to me, which tends to be a decimal form. Because if I told you to graph 5/3, that'd be a little difficult, but if I asked you to graph 1.6 repeating, chances are most people could do that. So 6 4/5 is really 6.8. So that's my first one, 6 4/5. The second number that they give us is the square root of 49. Hopefully you know that one off the top of your head. That's a perfect square, and it's 7. The next one is 6.3, repeating forever and ever. So I don't really need to plug that into my calculator because I kind of know what that looks like. And then this last one, square root of 57. That one I do not know off the top of my head, so I'm going to plug it in and I get 7.5498. We'll stop there. It goes on with more stuff. So now when I go to graph these things, I can tell that my numbers are somewhere in between 6 and 7. So let's make a number line that looks like that. We'll have 6, and then we'll do 1, 2, 3, 4, 5, and we'll do 7. So if I split it up into fifths, this would be like 6.2, 6.4, 6.6, 6.8, and 7. So if I plot these numbers, the first one, 6 and 4/5, is right here. 6, oh no. The next one, the square root of 49, is right here at 7. 6.3 repeating would be somewhere right in here. And finally, the square root of 57. Oh, we didn't make this big enough. We got to keep going. This would be 7.2, 7.4, 7.6, 7.8, and then 8. So this one would be somewhere about here. So just like last time, once you do this, writing things from least to greatest is super easy. We got 6.3 is the smallest, 6 and 4/5 is next, square root of 49, and finally the square root of 57. So that's it. Can you classify real numbers, and can you use the real numbers? So here's a couple tasks I want you to do. Classify these 3 numbers. So here's problem 1, problem 2, problem 3. And then problem 4, graph those on a number line and then order them from least to greatest. Make sure if you have questions about this that you write it down. We can go over them when I get back on Thursday. Hope you guys have a great day.